Welcome to the next lecture of mechanics of material. So in last lecture we were discussing about overhanging beam. So in this lecture we are going to study about again simply supported beam where multiple loads are present. If this type of loads are present, how to identify the point of contraflexure, how to identify the maximum bending moment, that we are going to discuss. Okay. So whenever any type of beam is given, the very first thing you have to do is you have to draw the you have to consider the beam is under equilibrium. That is the main consideration you have to do. Summation of horizontal forces 0, summation of vertical forces 0, summation of moment should be equal to 0. So when I take summation of horizontal forces, we are having only one horizontal load HA. So if you couldn't able to see, I will write this as HA. Here it is RA, here it is RB. Okay, so HA, RA, RB. So that is RA plus RB, RA plus RB is equal to, first one is summation of, this is because of summation of vertical force 0. So summation of horizontal forces HA will be equal to 0, that we have already discussed. So RA plus RB is equal to, what are the download forces? One is this UDL. UDL can also be represented as this horizontal load. This is your UVL. So what is the load because of UDL is nothing but UDL into length of UDL. So the length of this UDL is 2 meters. So 2 into 2. Okay. Next is plus, because of UVL we already know what is the length load because of UVL is nothing but half into base into height. Base is 3, height is 3. So half into base 3 into 3. So you will get it as 4 plus 3 3s are 9, 4.5. The value you are going to get it as 8.5. Okay. So the next is moment about point A is equal to 0. Sir, why always you take 0? You can take B point also, but I consider always, because we are solving from right to left every time, I am considering point A. Okay. Now when about point A we are having the horizontal load, that is the reaction B, UDL, UVL. So first let us take, because of that is nothing but clockwise is equal to counterclockwise movement. So clockwise movement is because of the UDL and the UVL. So because of the first counterclockwise you write, that is RB into distance between the B point and A, 2 plus 1 plus 3, 2 plus 1, what is the total distance now? 2 plus 3 plus 2 is 5, 5 plus 1 is 6. Now because of clockwise direction, let us take first UDL. UDL is 2 into 2 is the load. I will write 2 into 2 is the load. So where is the CG? The CG of this section will be present half of this. Okay, but whereas we want to find the distance from this point to the CG of this, from this point to CG of this, what will be the distance? So you have to subtract whatever the distance from here. So what is the 2's half is 1. So what will be this total distance? 3 plus 1 plus 1. So that is 4 meters. Correct. So I will write here 2 into 3 into 2 into 2 into 4 plus, now because of UVL, what we already know that from the apex the CG will be present at a distance of 2/3 meters. 2/3 meter. So from here the distance till this is nothing but 2/3 of the length. 2/3 into 3. Why 2/3 of the length? So first load because of that is half into base 3 into 3 into 2/3 into 3 is equal to RB into 6. 2/3 into RB into 6. So you will get this value RB is equal to RB into 6. I will write this because this is congested here. I will rewrite here into 4 plus half into 3 into 3 into 2 by 3 into 3. So this is the load. This is the load. This is the CG value. This is the CG value. Now what will be the answer? Let us check. So 2 into 2 into 4, 8, 16 plus of, I will use this brackets. So first bracket is 1 by 2 into 3 into 3 bracket 2 by 3 into again 3. So this is the old calculator. In this you have to use the bracket, then only you will get the correct answer. So RB is equal to 25. This RB value how will get? Divided by 6. So the answer is RB is equal to 4.167 kilonewton. RB is equal to 4.167 kilonewton. So RA value we can calculate 8.5 minus 4.167, because we have got the relationship RA RB as this. So 8.5 minus 4.167. So what will be the answer? You will get 4.33 kilonewton. 333. If you take 3 decimals here, you should take 3 decimals on the. So write this values here. RB is equal to 4.167. Here RA is equal to 4.33 kilonewton. Clear? So once you write this, go for shear force calculation. So shear force calculation, we know SF calculation. We will write SF calculation. So in shear force calculation, shear force before, what is the point we have taken? B point. Shear force before B point is equal to 0. Shear force at B is equal to RB, which is acting in upward direction. We will take minus 4.167 kilonewton. Next is shear force before point D. Before point D is equal to, that is minus RB plus, because of the UDL. What is the UDL? 2 into 2 is the load. So minus 4.167 into 4 will get as minus 0.167. Okay. Next is shear force at D. That will also be remain same because we don't have any point loads at this point. If you have point loads, we will add. If there is no point load, you have to take whatever is the load before that point, you have to take as it is. Now shear force before your C point. Before C point means this. So there is no load between these two. Whatever is the load before, that will remain as it is. Next is shear force at C. At C is also there is no extra load acting. So these values remain same. Next is shear force before A point. So when I say before A point, already we have calculated till C point. So before C means C already calculated. From here we have to add extra. So minus 0.167 plus, okay, half into base into height. So let us calculate this value. Minus 0.167 into 3 into 3 divided by 2. So the answer is, let us do 0.167. This is your answer. Okay, that is 3 into 3 divided by 2 minus 0.167. So what is the answer? 4.333 kilonewton. So before A we got. Now shear force at A. So whatever value we have before A, that we have to rewrite as it is. Along with that, we are having a reaction at point A. That is the value we are considering, 4.33. It becomes 0. Now let us draw the shear force diagram. So shear force diagram, baseline. So from the baseline, what is the value RB? RB is going in downward direction. So I am considering this RB. This point is minus 4.167. We got this value. From here again till D point. Let us go to D point. This is B. This is your D point. So minus 0.167. So minus 0.167 means this, because this is minus. So we will join this using an inclined line. UDL means inclined line. From here to here also we remain same. It remains same. So you can check the answer. It remains same. Okay. Next, from here again when I go to this point, we are getting an answer of 4.333. So I will draw this 4.333. So we have to join this to using a parabolic curve. Okay. Next, this is the value 4.333 kilonewton. So this distance I don't know. I have to calculate this distance, which is x. So this is your x. If this is your x, obviously I will mark all the lengths with respect to this value. This is your distance 3 minus x. Okay. So the total distance is 6. So obviously from here to here the remaining distance will be 6 minus x. Okay. 6 minus x. Clear? So we have got, this is positive, this is negative, because this is downward, this is positive. Okay. So what is this point? Let us take this point, A point, this is B point, C point. So this is D point, this is C point, Next, I don't know this point, I will consider this point as E. What is the importance of this point? What is the diagram we have drawn? We have drawn for shear force diagram. We know that when the sign changes from negative to positive or positive to negative, it touches the baseline. That point will give you the maximum moment, maximum bending moment if it is on shear force diagram. So the point in shear force diagram where it changes its sign from negative to positive, that point, at that point the bending moment will be maximum. So I have to identify the bending moment at this point. Okay, so we will try to solve that point also. First of all, we have to calculate the distance of that point. So I have considered from left support it is at a distance of x meters. Now I have to calculate shear force E is equal to shear force E means we are having either we can consider all the loads from the left side, or we can solve it from right side. Let us do once left to right solution, or you can, no need, you will get confused. So if this is x, so I will split this, because at this section we are having this part. So what is this length? How to identify that length? So we already know that if this is my UVL for 3 meters, it is for a height of 3 kilonewton per meter. So that is nothing but 3 meters will give you 3 kilonewton per meter. So 1 meter will give you 3 by 3 kilonewton per meter, correct? Per meter I am finding. So the value for 1 meter will be equal to 1 kilonewton per meter. For x meters, it will be x kilonewton per meter, correct? So the height of this will be equal to x. If this is x, this is also x. So what will be this remaining height? So the remaining height is 3 minus x, correct? So this will behave as a UDL and this will behave as a UVL, correct? So let us try to calculate the shear force at this point. So shear force at this point is because of this load and this load and this load. First is because of RB. RB is acting in upward direction 4.167 plus because of the UDL 2 into the length of UDL is 2. Okay. Next is plus, so this is upward, this is my downward. Downward means here we are having section 1, section 2. So because of section 1, x into 3 minus x. So x into 3 minus x, why? This is UDL 1 of UVL, UDL 1 of UVL. So this part will behave, this part will behave as a UDL. So if this is the length x, so what will be the distance? Already you have written 3 minus x. What will be the load because of this UDL? X into 3 minus x, x into 3 minus x. So x into 3 minus x, correct? Next is because of the UVL present at the top. So present at the top is half into base 3 minus x into, okay, x into again 3 minus x. Why 3 minus x? If this is 3 minus x, obviously the height is also 3 minus x. Clear? So what will be this answer of this should be equal to 0. Answer of this should be equal to 0. That is 4.167 plus 4 plus, so if this you multiply this 3x minus x square, okay, plus of 3 minus x the whole square divided by 2. So the value for this is minus 0.167 plus 3x minus x square plus 9 plus x square, correct? Expansion of this a minus b the whole square, a square plus b square minus 2ab whole divided by 2. Okay, so this is 0. You can do the LCM. We will get minus 2 into 0.167 plus 6x, okay, minus x square minus 2x square, okay, 6x minus 2x square plus 9 plus x square minus 6x whole divided by 2. So this 2 goes on other side, it will become multiplication, it will get cancelled. So the answer is minus, so we will do this, minus 2 into 0.167 plus 6x minus 2x square plus 9 plus x square minus 6x plus 6x minus 6x cancel. Next is plus x square minus x square, so minus x square. Okay. So the value of this is constant, this is constant. So what is that constant value? Minus 2 into 0.167, okay, plus 9. So this is 8.666 we are getting. Minus x square plus 8.667 is equal to 0. X square is equal to minus, sorry, plus, because this x square goes on other side, becomes positive 8.667. So x square is equal to 8.667, that is under root of answer, you will get it as 2.943. 2.943. So the x value you are going to get it as 2.943. If you are getting confused in this, you can let us try to solve it from left to right. So what is left to right is nothing but you have to take from this and this. So here we are having one load which is right, left to right is RA, that is RA value is 4.333 minus, because of this UDL you have to take, so that is half into base x into x square is x into x is equal to 2. Why x into x? The base of this is x, obviously the height of it is x into x. So you can take this half into x square is equal to 4.333, because this is in minus, going on other side, x square is equal to 8.667, x is equal to 2.943, which we have got same value. Either you do right to left or left to right, you will get the same answer. Okay, see here, downward to upward force I have considered as positive, because we are solving from right to left, left to right. When you solve from left to right, whatever the sign convention we have taken, opposite we have to take. So the upward force should be taken as positive, the downward force should be taken as negative. So we have got the values same. So I will mark that value, x is equal to 2.943 meters. Okay, clear. So what will be this distance? We will try to calculate. So now take the bending moment. Now let us solve for bending moment. So bending moment at point B is equal to 0. Bending moment at point D is equal to, because of RB, you can see this is D point, this is RB. So RB value is 4.167 into, so this is rotating in anti-clockwise, so positive, into 2 minus 2 into 2, because this is UDL, this rotates in clockwise, so minus 2 into 2 into CG of that is 1. So what will be the answer? Let us check. So answer is 4.167 into 2 minus 2 into 2. So the answer is 4.334, okay, which is acting in upward direction. Now let us take bending moment at point C. At point C means we are having same loads, but the distance is different. So RB is now 4.167 into the distance between these 2 points, point C and point B. So we have to consider this total distance. What is the total distance? Is 3. Total distance is 3. So into 3 minus 2 into 2 into, now we have to take the distance from CG to this point. What is this distance? So this is half, this is 1, obviously 1 plus 1 is 2. 1 plus 1 is 2. So we are considering this as 2. Now let us try to solve this problem. 4.167 into 3 minus 2 into 2 into 2. So we are getting it as 4.501. Okay, 4.501. Now bending moment at point D. 4.167 into 3 minus 2 into 2 into 2. You are getting it as 4.501. This is kilonewton meter. This is kilonewton meter. Okay. Then next is bending moment at point D. Where is your point D? D already you solved. No? So bending moment at point E. So where is your point E? Here is your point E. So either you can solve it from left side or you can directly solve it from here. It's up to you. Okay. Both the ways we are going to get the answer. Now I will try to solve. I will write here right to left. I will write, because why I am going to right to left every time when I come to this point is nothing but this is nearest point, and we can easily calculate when compared to that of other values, because here we have to consider this load and distance we have to take every time. That is a big hectic. Or we can do both the methods. I will do both the methods so that you will be much thorough with this. So first of all, let us try to go traditional way. That is 4.167 into distance from this point to this point. this point to this point. Already we know from this point to this point the distance is 1 plus 2 3. So what is this remaining value? We have got this 2.943. So what is the remaining value? 3 minus 2.943 will be 0.007, 0.057. So what will be the total distance? This total distance is nothing but now 3.057, correct? So 3.057. So let us multiply 3.057. Clear? Next is minus, because of this UDL. UDL is now 2 into 2 into the CG is present at a distance of 1 meter from D point to this point. Now from here to have to take this. Already you have calculated till C point the distance from CG is 3. So 3 plus 0.57. Sorry, 2 plus 0.57. So here, see here, 2 we have already calculated till C point. So 2.057. Okay. Next is because of this UDL you have to take. Because of this UDL and UL you have to take. Now let us take because of that UDL and UL. That is minus, because of UDL is, what is the value of that length? 0.057 into 0.057. This will give you the load and CG. So what will be the CG of this particular length is half of it. Half of it is nothing but 0.057 divided by 2 minus again because of the UVL which is present above. Because of the UVL which is present above. That is half into 0.057 into 0.057 into 2 by 3 of 0.057. So you calculate this, you will get a very complicated issue. So to avoid this only, I have told that, so bending moment about point E, we can calculate from right side. So it will become much easier for us, much easier from us. So what is that value is nothing but, let us try to take in this way. So that is, what is this direction? So what is the direction? This is rotating in clockwise. So in left to right case, CW is positive. So I will take this as positive. 4.333 into distance is 2 by 3rd of 3, nothing but 2 minus, what will be this distance? What will be? This distance is 2 actually. I have already calculated the distance. Sorry, the distance is 2.943. Sorry. 2.943 minus, because of this UVL. What is that? UVL is nothing but half into base 2.943 into height 2.943 into what will be the CG. So from this point the CG is present at a distance of 1 by 3rd of x, at a distance of 1 by 3rd of x, that is 1 by 3 into 2.943, 1 by 3rd into 2.493. Let us try to calculate 4.333 into 2.943 minus of 2.943 into, so this is 3 times, 1, 2, 3, so you can directly make it cube. So I will make it cube, okay, cube divided by, you see 3 2s are 6. So what is the value you are getting here is 8.5. What is the value you are getting here? 8.5. So see among the other values, so this is 4.3, this is 4.5, the same value you will get here also. So you are getting it 8.5. Next is bending moment at point A. Bending moment at point A. So how to calculate the bending moment at point A is obviously it will, because this is above the support. At support the bending moment will be 0. So I can directly take it 0. No need to much bother about this. Now we will go for bending moment diagram. So how will the bending moment diagram will come? Let us draw. So this is your 0 baseline. So here we have got 0. Here we have got the value of 4.334. So I am drawing this. Since this is an inclined line, this will be a parabolic. This will be a parabolic curve. So we will write here parabolic. So here it is parabolic. So obviously in bending moment you will get cubic. Next, so that is next point is 4.5. From here we have gone to a small height of 4.5, which is again, since this is a straight line, we have to join these two by using an inclined line. So I will write this inclined. Okay. Next is from here to this point you are going to a rise of 8.5. From 8.5 to again you are going to get 0. So this is cubic curve. This whole diagram is positive. This is your cubic curve. So I am clear with this. So this is 4.334. This is 4.501. This is 8.503 kilonewton meter. You should write this values also if possible. Kilonewton meter. So this is your positive bending moment diagram. So in this way you have to solve for multiple loads. In this way you have to solve for multiple loads. Okay, clear? So with this we will stop this lecture, and we have seen the how to solve when it is multiple loads.